Hello students, welcome to mathematics class. Students, this is part 2 of the chapter Algebraic expressions and identities. In this part 2, you will be learning like terms and unlike terms. Later, you will be doing addition and subtraction operations on algebraic expressions. Now, coming to the one of the important, try these from the textbook in the page number 138. We have learnt monomials and binomials, trinomials and polynomials. Here we are given the task of identifying among the given algebraic expressions monomial, binomial, trinomials. First one, this minus z plus 5 minus z plus 5, it has only two terms, that is minus z one term and 5 second term. So, it is a binomial. So, by watching number of terms in the given algebraic expression, we can say that it is binomial. And in the second one, x plus y plus z, it has three terms, that is x is one term plus y, that is y is second term plus z, that means third term is z. So, x one term, y second term, z third term. So, based on that we say it is trinomial. Next, in the third one, that is y plus z plus 100, it has three terms again. One is y, that is first term, and second term is z, and third term is this number 100, which we call constant term. So, it is also one more term. Based on this number of terms, I say this is trinomial. And in the fourth one, that is AB minus AC, AB is a first term, AC is another term with the negative sign. So, I have totally two terms. So, based on that, I say it is binomial. And in the fifth one, I am given only number 17 alone. So, it is a constant term first of all, and it is only single term. So, I say it is monomial. So, children, this is how we classify the algebraic expressions based on the number of terms. Now, coming to the second question, construction of three binomials. We are asked to find, we are asked to construct three binomials with a condition that we have to use only variable x. So, I will write solutions for the second question. So, I am constructing first binomial using only variable x as I can say x plus x square plus x cube. This is one binomial and has got only variable x. Next, minus 2x plus 5 x square minus 7 x to the power 5 and that is second. I can use now x cube plus x to the power 5 minus 11 x to the power 7. So, this is one more trinomial. Oh, I'm doing all these trinomials now. Sorry. Let me go for preparing only binomials using the variable x alone. I have, these are all trinomials anyways. So, I am taking away for that reason. Now, let us see how can I convert or how can I construct binomials. Binomial means it has to have only two terms now. So, let us take now 2x minus 3. It has got only one variable x. So, it is a binomial. Minus 11x plus 4x square, it is again a binomial. Next, 1 by 2 x square minus 5 by 2 x cube, it is a binomial, only having variable is x. So, these are all binomials. Now, coming to this second sub question B, 3 binomials with the variable x and y. So, I can use x plus y is one binomial, 2x minus 3y another binomial, x square y minus 11, it is a one more binomial having only variables x and y. So, this is the way we can think of. Now, third one, 3 monomials with the variable x and y. So, 11x y is one monomial, x square y is one more monomial, minus 3 by 8 x square y cube is one more monomial. So, I have done using the variables x and y. Now, 2 polynomials with 4 or more terms, so I will make x plus 7 x square minus 5 y plus 13. So, I have used variable x and y as well as constant having 4 terms. I can generate n number of polynomials, means many number of polynomials with 4 or more terms, having one variable alone, having more than one variable also. So, etc. we can generate. This is how you need to construct. Now, coming to the important topic called like and unlike terms. Children, here this is a new topic, but still you have learnt this in 6th and 7th. To make you recollect, here I am giving you one task of thinking, that is, look at these algebraic expressions, but all these different algebraic expressions are having one and only one terms, that means I say monomials. So, here I have given you monomials by their nature because having only one terms. So, they are all monomials, or I say terms. So, watch these terms and identify amongst them which are like and which are unlike. Children, very simple. Like, if I am calling any two terms as like, then they must have same variable part. Okay. So, what I am going to write is terms, sorry, here let me write terms having same variable part are called as like terms. So, if I am calling any two or more terms as like, then they must have same variable part. You know, here 7x, in this term x is the variable part, 7 is a constant part or numerical part. So, now if I want to identify the like terms, I must look for same variable part. So, 7x, 14x, minus 13x, they are all like terms. So, like terms, first I will give you example. First one, 7x, 14x, minus 13x are like terms. You know reason? They have same variable part, that is x, x, x. Then this 5x square and minus 9x square, they are all like terms. Why? Because they have same variable part as x square, x square. Third, 7xy and minus 5yx, which I can write as x into y equals to y into x. You know, this property is called commutativity under multiplication. So, commutativity under multiplication says, is it commutativity? Sure? Yes, it is also called as abelian property. So, commutativity under multiplication says product of any two numbers is same, however, or in whichever order that they are multiplied. So, based on that, x into y equals to y into x, therefore, this yx can be written as xy. So, 7xy and minus 5xy are like terms. So, because of that, the same variable part xy, xy. Children, now I have few questions. Question 1, why are 7x and 7y are not like terms? As they have different variable portions, isn't it? It has got variable portion as x and this 7y has variable portion y. So, that is why they both are unlike terms. So, the terms having different variable portion are called unlike terms, that is it. You know now definition of unlike terms also. The terms having different variable portions will be called as unlike terms. So, example for unlike terms will be 7x and 7y. One more question, why 7x and 7xy are not like terms? Same reason, they are unlike terms because they have got different variable portion, though there is x here and here x, but in the 7xy along with that 7x we have got, or along with that x variable portion, one more y, that factor one more. So, they have different variable portions. 7x and 7xy are unlike terms, though there is variable x in both. Understood? Here and here variable parts are different. Now, coming to the third question, why are 7x and 5x square unlike terms? Again, they are also having different variable portion. You watch here, the variable portion is x that means x is for only one time as a factor. But whereas in this 5x square, you could see 5 being one factor, another x being for twice that factor, then only you will get 5x square, 5 into x into x. That means here in this variable portion you could see the power of the variable x being 2, and whereas in this 7x power of the variable being 1, that means it has only one time as a factor. In toto, I say they have a different variable part. Here the variable part is x, here the variable part is x square. So the terms having different variable portions will be called as unlike terms. That's it. Then you know now, with this knowledge, let us go for little work. Write two terms for each like terms. So I want for this 7xy two more terms like. Suppose if I say minus 13xy is one more and 1 yx, one time yx, they both are like terms to this. Similarly, can we write for this second and third? Obviously we can write. Come on. See, since it is a class having not you with me, I am unable to listen to you or watch your thinking and understand how much you are making it out. But surely children, I want you making your effort. Okay, so I am giving these two as a work for you, and later you can check and you can personally call me and ask me are they like or not like, or you can fall back to me through WhatsApp. Now children, now let us go for one more important topic called addition and subtraction of algebraic expressions. See children, here in this I am showing you from textbook straight away the concept. In earlier classes we have also learnt how to add, subtract algebraic expressions. Here I have given example. One algebraic expression is 7x square minus 4x plus 5. Another algebraic expression is 9x minus 10. While adding, when we are adding, we will write like terms under like terms. Remember, if you are adding, like terms are only added or subtracted. So this is very important point which you have to remember. If at all you want to add any two terms, you should see whether they are like terms or not before you adding them or before you subtracting them. So only like terms can be added, can be subtracted. So in this two different algebraic expressions, I am looking for like terms and writing like terms under like terms. So it is a procedure. We write each expression as a separate row. This is a row. This is how I have written. Then while doing, we write like terms one below the other. So for minus 4x, 9x is a like term, so I have written 9x under minus 4x only. For 5, minus 10 is a like term, so under 5 I have written minus 10. Now while simplifying, 7x square has no like term, so it is written as it is. Later minus 4x and plus 9x, if you simplify, How to simplify that? It is minus 4 plus 9. How you have done integers addition subtraction similarly to be done. That's why I told addition and subtraction of integers plays important role not only in number system, in algebra, in even linear equations in one variable. So you have already well practice of this. Minus 4 plus 9 is a plus 5. So plus 5 along with that variable portion we will write. So plus 5x. Now this plus 5 and minus 10 on simplification you get minus 5, it is written. So this 7x square plus 5x minus 5, this trinomial is the resultant, or it is called sum of these two algebraic expressions. So children, very important. With one more example I will explain this concept. Here you have got adding three algebraic expressions, 1 up to here, 7xy plus 5yz minus 3zx. Second up to here, that is 4yz plus 9zx minus 4y. Third one is this one, minus 3xz plus 5x minus 2xy. Suppose if you want to do the addition of them, as they said to add, what we have to do? First we have to write them as 3 rows where like terms one below the other. Very important, because only like terms are added. Now I have written that. So 7xy plus 5yz minus 3zx. Next, remember children, 4yz comes under 5yz because they both are like terms. 9zx comes under minus 3zx because they both are like terms, and this minus 4y has no like term, so I wrote little farther. Then in the third one, minus 3xz, xz, 3xz is same as zx, so I have written that here. So I am you can say rearranging. So we will rearrange the terms, and write. See, minus 2xy is a like terms to 7xy. 7xy and minus 2xy are like terms. So first I am taking minus 2xy, and this 3 minus 3zx. See, I am taking terms, you know, term will have along with its sign, a part along with its sign. So the nature of 3xz is minus, so minus 3zx. Nature of 2xy is minus, so I have taken that first. At last, plus 5x, which has no like term at all. Now we will go for doing addition. So 7 minus 2, 7 minus 2 gives you 5xy. Children, here as I already said, this important note, xz same as zx. Now the solution is 5xy, 5yz and 4yz, both are plus sign, with the plus sign nature. So we will have plus 9, plus 5 plus 4 is plus 9yz, minus 3zx plus 9zx minus 3zx. Here in total I have minus 3 plus 9 minus 3 plus 3, sorry, minus 3 plus 9 minus 3. It put together gives you plus 3, because minus 3 minus 3 is minus 6 and 9 minus 6 is plus 3. So we will get plus 3zx, and 5x has no like term at all in the rest of the two algebraic expressions. So 5x comes as it is. and minus 4y also has no like term in the rest of the other two algebraic expressions, so comes as it is. So this polynomial is the sum of these three algebraic expressions. So children, very important, only like terms are added. Here the term minus 4y in the second expression and 5x in the third expression come as it is, are carried over as they are, since they don't have any like terms in the other expressions. So with this I am going for one more important work further, children. One more example I will take. So we will take one more example, example number 2. See children, in this example number 2, we are asked to do subtraction of this algebraic expression from this algebraic expression. So this becomes subtrahend. Which one? Subtrahend is 5x square minus 4y square plus 6y minus 3 is subtrahend. Okay, this is subtrahend, and from this gives minuend. So always minuend will be on top and subtrahend will be in the down. Okay, so solution will be, first I have written minuend in the top, subtrahend I am writing it down. Remember children, while subtracting also we will write like terms under like terms. So 5x square is like term with 7x square, so I have written down below. Minus 4y square is a like term with 8y square, so I have written that below. So there is no like term for minus 4xy, so I left it as a blank. Now this 6y is a like term with minus 3y, so I have written down below. For this 5x, no like term in the subtrahend, so I have written blank. Now for minus 3 there is no like term here, so I have written last. Remember children, this is note very important in subtraction. The sign of each term of each term of subtrahend will change. So very important this point. So while doing subtraction, the sign of each term of the subtrahend, will change. For example, if it is positive, it will turn to minus. If it is negative, it will turn to plus. Plus will become minus, minus will become plus. Now the nature of 5x square is minus 5x square. This nature of minus 4y is plus 4y. Nature of 6y is minus 6y. And nature of this 3 is plus 3 now. Now the new answer will be 7 minus 5 gives you 2x square. Minus 4xy has no like term at all down below, and it is there in minuend, so it does not have any change in its sign, comes as it is. Now plus 8 and plus 4 becomes plus 12y square, and this 5x does not have a like term at all in subtrahend, so comes as it is without change of the sign because it is there in minuend. Now minus 3 and minus 6 in results minus 9 with the variable y, minus 9y, and minus 3 it is there in subtrahend. Now it becomes plus 3, so comes with that same plus 3 in the result. So this is the result of operation subtraction, which we call difference. So this is the result algebraic expression. So 2x square minus 4xy plus 12y square plus 5x minus 9y plus 3. In page number 139, this example is given in your textbook. You can watch it and cross check whether I have done correctly or not. Children, very important note what I said, the same thing in detail they are discussing. This note is what I mentioned here. The subtraction of a number in the same as addition of its additive inverse. Thus, subtracting minus 3 is the same as adding plus 3. Similarly, subtracting 6y is the same as adding minus 6y, and subtracting minus 4y square is the same as adding plus 4y square, and so on. Thus, the signs in the third row written below each term in the second row is subtrahend, simple, and third row, this is what they are mentioning. That means we are changing the symbols of this subtrahend. The terms of the subtrahend are getting changed. Help us knowing which operation has to be performed. So I simply mentioned with this simple note, that is, while doing subtraction, the sign of each term of the subtrahend will change. That's it. So with this simple note, this entire concept is remembered. Okay, children. Now with this I have completed operations addition and subtraction of algebraic expressions. Here I am going to give you exercise 9.1. There are 4 questions and further sub questions. You can pause the screen and note down questions and try on your own. One thing, if you have a textbook, take out exercise 9.1, which is there in the page number 140, and attempt on your own. In our next class, I am going to discuss from this exercise 9.1 few questions, not all, I will discuss few questions only, maybe 1 or 2 out of this mains for your understanding, and I will go further to the another important topic called multiplication of algebraic expressions, because addition of algebraic expressions is done by you extensively while we were learning linear equations in one variable. Okay. So, exercise 9.1, question number 1 to 3, you can pass the screen and solve on your own, and next question number 4, now you pass this screen and solve these 3 questions also. So with this I will wind up our session. So take care of yourself, children. Jai Hind. Thank you.